My project is about understanding how COVID-19 outbreak affects people by running sentiment analysis and topic modeling of tweets relating to the COVID-19 outbreak. The motivation behind this project is the fact that there are so many different forms of suffering due to the COVID-19 outbreak. Thus, there are so many different sentiments regarding different topics. For example, people who are immunocompromised are more anxious about recovery if infected than people who are healthy. In the same way, people who are wealthy enough are less anxious about food availability than people who are less wealthy. Thus, food availability will have a positive sentiment from people who are more wealthy than that from people who are less wealthy. The workflow of this project has changed from the first part. I tried to run topic modeling first, but then I found out that it didn't quite work because I didn't know how to group tweets based on their topics. I tried to run sentiment analysis first and then group tweets based on their sentiments, and then later on run topics modeling on each of these groups. To run the sentiment analysis, I had to build a sentiment analysis classifier that uses the naive Bayes, which is supervised. That means that I had to mine 1,000 tweets first and then label them manually one by one based on their sentiments. So there are 3 sentiments: positive, neutral, and negative. So P for positive, N for negative, and E for neutral. First, I will run that classifier on a different set of tweets, 5,000 tweets this time, and then group the tweets based on their sentiments: positive, negative, and neutral, and then run topic modeling on group of positive tweets and group of negative tweets. Before we go to results so far, I will show the Jupyter notebook that I used to come up with this result. So this Jupyter notebook contains all the code that I used to come up with the results of my project. So the first step is to install all libraries that we will need. So basically those libraries for data analysis, and the most important one is NLTK and Tweepy. We use Tweepy to get tweets out of Twitter. One needs to have a Twitter account and get a developer account to get these 4 unique keys and tokens to then use Tweepy to get the tweets that we need. So this step is collecting tweets. So I collected 1,000 tweets in mydata.csv for building and testing the model for sentiment analysis, and a few days later I collected 5,000 tweets in analyze.csv, on which I will run the model that I built and topic model. So basically we can just use this code that is available online with some tweaks to limit the tweets and save it as CSV. So I used the keywords COVID or lockdown or stay at home, so I will get tweets that contain at least one of these that is in English. And the next step is what I think is the most difficult step, which is cleaning tweets. DF is the data frame representing the tweets in metadata.csv, and df1 is the data frame representing tweets in analyze.csv. So df will have 2 columns, which is tweets and label, because I labeled them beforehand to be N for negative, E for neutral, and P for positive. I then defined some functions that will help clean the tweets, and looking at the kinds of hashtags that tweets have, I didn't actually use this in order to come up with the product of this project. I was just curious about the hashtags of these tweets. for sentiment analysis, so there are many steps in sentiment analysis, like tokenizing the tweets, which is basically just splitting up the tweets into words. And then, so this is part of the cleaning up, so removing links and users. So like at something, so we want to remove that, and also links. Images are represented in tweets as links, so running remove links on Twitter will remove all links including images. And then lemmatized sentence, part of the normalizing tweets. So normalizing tweets means just converting words to its base. So for example, wants and wanting and wanted will be converted to be just want, so just the of this thing. And then stop words, so these are the words that we want to remove from the tweets that don't really tell us anything. For example, like on and off and over, under, again, further, and etc. So we now have 4 columns in DF, which is tweets labeled, hashtags, and clean tweet. So we want to see what words appear more in tweets that are labeled as positive, negative, and neutral. So we use FredDist from NLTK to see the most common words in positive, negative, and neutral tweets. We won't actually use this because we will use naive Bayes instead, but I think this is an important information to know what words are more dominant in positive, negative, and neutral tweets. So now to actually build a sentiment analysis model, we basically get tokens for positive model, negative, and neutral models. So these variables will be in the form of dictionary that maps words to true. This will map those into the sentiment. Positive dataset will have a list of tuples. The tuple will have the dictionary, this dictionary, as its first element, and positive, which is the sentiment, as the second element. Remember that we had 1000 tweets for the training and testing dataset. So I shuffle those tweets and use the first 850 tweets to train the model, and the other 150 to test the model and see how accurate it is. So we can simply import classify and naive Bayes classifier from NLTK and then train it using our train data, which is the first 850 tweets. And then we will then try to classify the next 150 and see the accuracy. I ended up with a model that is 39% accurate, which is pretty bad, remembering that a model that purely guesses the sentiment of each tweet would have 33% accuracy. If it's purely random, it will be 33% accurate. And we can also see that the words that are dominant in the sentiments are not actually representative of those sentiments. Like everyone is dominant in tweets that are positive, but the word everyone doesn't really represent a tweet that is positive, and so on. But anyway, since the classifier is not very accurate, the final product of this project would not be accurate either. But I still think it's important to see how it works all the way through. So we clean the tweets using the function clean tweet that we have defined above and add it to a new column in the df1. And then we tokenize it and we run the classifier on those tweets. So this is just checking that this tokenized tweet example is classified as negative using our model. So it's accurate to some sense, but not really that accurate. We will then add a column called sentiment to the F1. So for example, this tweet that says, "Congratulations, something, something, something," is labeled as positive, which makes sense. I then group those tweets based on their sentiments, so I will have positive and negative tweets. I disregard neutral tweets because the aim of the project is just to see the topics that are talked about in a more positive tone and a more negative tone. So everything in between is being discarded. So we ended up with 1,069 positive tweets and 2,600 negative tweets, which makes a bit of sense because in these trying times, people usually tweet about negative stuff more than positive aspects. I then run topic modeling on positive tweets and negative tweets. So this whole code is available online on the tutorial linked on the top of this project file. So these are the topics that are generated from the tweets that we have labeled as positive. Remember that our classifier is not very accurate, so these topics are not also very accurate. But these are the 3 topics generated from the positive tweets. Unfortunately, these topics are not very distinct from each other, and I also didn't deal with emojis, so we can't really tell what emojis these are. So I collected the 5,000 tweets when the news about Dominic Cummings from the UK was violating the stay-at-home order, so it was being talked about, but somehow it's classified as positive. So at least this topic is a bit specific, but these 2 topics are not very specific. And then for negative tweets, we get these 3 topics. These topics are not very diverse either, but you can see that this topic might talk about something that has to do with government, and this topic about the people, but we have people here also. So and then for this topic, maybe about COVID-19 case reports, and we have Genovia in there, and then I have summary of project and work done, so I have walked through everything that I have done for this project. So the reflection is that the classifier is not very accurate. I think the reasons might be because 1,000 labeled tweets may be too little, and when labeling those tweets, I may have been a bit subjective, and then the process of cleaning the tweets might not be thorough enough. One good suggestion is to look at the images and the text contained in those images to get more information out of a tweet, because tweets are really too short to contain very useful information to extract from. So extracting information from emojis and images might be good to make this project better. But through this project, I have also learned that dealing with real-world data is not as easy as I thought, but it is a rewarding experience because now I know how to run sentiment analysis process and topic modeling and see what's out there in terms of AI and NLP libraries and technology that people have been using. Oh, and I also read an article about using transformers to do sentiment analysis, but it was a bit too advanced for me, so I decided to just use naive Bayes. Finally, these are the links to the tutorials that I used to work on this project. Thank you.